Hello, my name is Sui and I'm from Sci Enza, Science Center at the University of Pretoria. Today we're going to be talking about conductors and insulators. But first we have to start with circuits. What is a circuit? A circuit is this over here. It simply allows current to flow through in a loop from one end to another without interruptions. As soon as it's interrupted, the circuit is broken and the electricity can no longer flow. Right, so let's have an example or a demonstration. Here we are. The circuit is on, but if I had to remove one of the wires, the circuit breaks. Once we plug it back in, the circuit is once again complete and the electricity can flow through. Alright, so what are conductors and insulators? What makes a conductor good or bad? Alright, so there are different types of materials we have. We have a lot of materials. Here we have a list of materials. A rubber band, the one that we always use. This is a plastic straw, the one used to drink juice with. This is a cardboard box. This is the ice cream stick that we use. It's a wooden ice cream stick. This is aluminium foil. This is just a simple piece of paper. Here we have a steel nail. This is a candle wax, the one that you use at home for load shedding. Right, and these are alligator clips. This we will get to into more detail a bit later on. Alright, so what makes a conductor good or bad? Right, so here we have the circuit that we have used a little earlier. We're going to be using this circuit to determine whether these materials are either good conductors or good insulators. So a conductor is something that allows current to flow through rather easily. It does not restrict the current flow, it allows the current electricity to flow through rather easily. What is an insulator? Well, an insulator is what stops electricity from flowing through, specifically current electricity. It stops electricity from flowing through. So those are what conductors and insulators does. So in order for us to determine which of these are good conductors or good insulators, we have to test each one by using the circuit we have. So here is our circuit set up with our two terminal points. Once we connect these two terminal points, the circuit is complete. So now we're going to be using our materials to contact whether the current electricity flows through the object or does not. If it does not flow through the object, that means it's a good insulator. But if it does flow through the object, it means it's a good conductor. So here we will start our test. Alright, so here we have our first material, it's our rubber band. We will be testing by contacting the two terminals to see if the electricity can flow through it. Alright, they are under contact. The switch is on, but we don't have any electrical flow. Therefore, this is a good insulator. Right, we'll put our good insulators in one side. Right, now here is a straw. Nice plastic straw. Good insulator, good conductor, we will find out by contacting the two terminals. It's a good insulator. So these two terminals are connected to the plastic straw. Right, good insulator. So now we're going to do a cardboard box. We will test the cardboard box. Also a good insulator. Right, fantastic. But what about aluminium foil? What do you guys think would happen? Is it going to be a good conductor or a good insulator? Let's find out. It is a good conductor. It conducted the electricity, so the electricity can flow straight through the aluminium foil. Alright, so this is an ice cream stick. We're going to be testing whether ice cream stick is a good insulator or conductor. It is a good insulator because it does not allow the electrical current to flow through the circuit. Alright, so next is a steel nail. Alright, this is a big nail, so let us determine whether it's a good insulator or conductor. It seems like it's a good conductor. It allows electrical current to flow through the nail. So it completes the circuit. Alright, so here we have our wax, our candle wax. Right, here we will test the candle wax and it is a good insulator. Right, so this is a good insulator. So here we have one of our final ones is what we call an alligator clip. You'd notice that these two ends are metal, but it's wrapped in something. It's wrapped in a plastic or sometimes it's wrapped in rubber. Any reason why they would be wrapped in rubber? It's because it's a good insulator. So for high voltages, these insulators are to protect us from getting electrocuted, and these metal tips are for contact on our circuit. So here we will be connecting our circuit with our metal alligator clips, and it completes the circuit. What do you think would happen if we used the rubber part? So we will only contact each terminal with the rubber, and it seems there is no contact. So here is a better view of what's inside this alligator clip. Here is the wire. It's made out of copper, which is a good conductor. It conducts electricity really well. So this is what's inside the insulated part. Do you guys have any ideas of why we have conductors and insulators? Why do we insulate conductors? It's because we do not want to get electrocuted. So here we have a plug that we have everywhere in our households. Here we have 3 wires. These wires are all copper wires. When this is plugged into a socket and we had to touch these things, we'd get electrocuted. So in order to protect ourselves, we have insulators covering them. This is why all the plugs and extension cords and all the electrical devices at home are usually covered in insulators. Alright, so there are 2 types of conductors and insulators. They are thermal and electrical. And today we have experienced the electrical insulators and conductors. So we learned that conductors allow electricity to flow through freely, while insulators stops electricity from flowing freely. We learned that insulators protect us from getting electrical shocks, but conductors, if we touch conductors directly, we will get electrocuted if connected to a switch. Alright. So I hope you guys have learned what the difference between insulators and conductors are. Remember, we are from Sci Enza at the University of Pretoria. Thank you.